Hello students, this is section 1 of chapter number 1, relations and functions. Relations and function is continuation of a chapter in +1 with the same name. So in +1 you already studied how to find A cross B when two sets A and B are given. That is actually Cartesian product, how to find Cartesian product of two sets. Now what is relations already studied. Actually, what is relation? Relation is subset of A cross B, right? And all subset of A cross B are relations. You all know what is empty relations. So what is empty relation? A relation from A to B is called empty if no element of A is related to any element of B. And you studied what is universal relation. A relation from A to B is called universal relation if each element of A is related to all elements of B. In this chapter, we will learn more about relations, different type of relations like reflexive, symmetric, transitive, etc. And in +1, we studied about functions, difference between relations and functions. Actually, what is the difference between relations and functions? All relations are not functions. A relation from A to B is called a function if all elements of A has one and only one image in B. That is the definition of function. So you all know how to find a domain of a function, how to find range of a function, what is codomain, etc. So in this chapter, we will learn different type of functions like 1-1 function, 1-2 function, bijective functions, etc. So we can start this chapter with a few examples from +1. After that, we can start our +2. Okay. Dear students, since I don't have blackboard in my home, I am trying another method. Nowadays, many teachers are using this method. So let me try. Okay, we can start chapter number 1. Chapter number 1, relations and functions. So we can start this chapter with one example. Let's consider one set A. It contains two elements, 1, 2, and another set B, which contains three elements, 2, 3, 4. Now my first question is how to find A cross B. A cross B. A cross B means you alternate all ordered pairs from A and B, where X coordinate should be from A, Y coordinate should be from B. So first ordered pair that we can form is 1, 2. Second ordered pair 1, 3, and third one 1, 4. I am fixing this one and forming ordered pairs by using elements of B. Now take second element of A, that is 2, then form ordered pairs 2, 2, 2, 3, 2, 4. Okay, then close the set. So total 1, 2, 3, 4, 5, 6 elements are there. If you want, you can find B cross A also. For finding B cross A, you have to take first element from B and second from A. That means X coordinate from B and Y coordinate from A. So take first element 2. 2, 1 will be first order pair. Then 2, 2. Take second element 3, 1, 3, 2. Then 4, 1, 4, 2. So number of elements are same in A cross B and B cross A, but A cross B is not equal to B cross A, because ordered pair 1, 2 is not equal to ordered pair 2, 1. This is the way we can find A cross B and B cross A. Now, how to form relations. Take same set A and B. I am forming a relation. Let R be a relation from A to B, defined as R equal to set of all AB such that B equal to A plus 1, where A belongs to capital A, B belongs to capital B. That means element A related to element B if it satisfies this equation. So first you have to write elements of R. Suppose if value of A equal to 1, what will be value of B? Value of B equal to 2. That means 1 is related to 2. If value of A equal to 1, value of B will be B equal to 1 plus 1, right? 2. That means 1 is related to 2. This 1 is related to 2. Then take second element of A, that is 2. When A equal to 2, B will be 3. So 2 related to 3. In A there is no third element, so we can close this set. So R contains only 2 elements. 1 is related to 2 and 2 is related to 3. Clearly R is subset of A cross B. And all subsets of A cross B are relations. This is actually R1, we can write relation 1. Okay, now consider example 2. A contains 3 elements 2, 3, 4, B 4, 5. Let R be a relation from A to B defined as R equal to set of all AB such that B equal to A plus 2, where A belongs to A, B belongs to B. Means element A related to element B if it satisfies this condition, that is B equal to A plus 2, where A belongs to A and B belongs to B. That means any element of A is related to A element of B if it satisfies this condition. Now we can find elements of R. That means which are the elements related. So when A equal to 1, what is the value of B? B equal to 1 plus 2, that is 3. But 3 is not in this set. That means 2 is not related to any element of B. Now take second element, that is 3. When A equal to 3, value of B will be 5. That means 3 is related to 5. So first element of R is 3, 5. Now take third element, that is 4. When A equal to 4, value of B will be 6. But 6 is not in this set. That means 4 is not related to any element of B, which implies that relation R contains only one element. Clearly R is subset of A cross B. Okay, now consider example 3. Let A equal to set 1, 2, 3, B equal to 4, 5, 6, and let R be a relation from A to B defined as R equal to set of all x, y such that y plus x greater than 20, where x belongs to A, y belongs to B. Instead of A, B, we can write x, y also. So x is related to y if sum of x and y more than 20. So let us find elements of R. R equal to, say take first element of A. When x equal to 1, take y equal to 4. 1 plus 4, that is 5, which is not more than 20. 1 plus 4 is not more than 20. So we cannot, 1 is not related to 4. Same way take 1 and 5. 1 plus 5 is not more than 20. 1 plus 6 is not more than 20. So take second element. 2 plus 4, that is 6 only. 2 plus 5, 7. 2 plus 6, 8. Now take third element. 3 plus 4, 7. 3 plus 5, 8. 3 plus 6, 9. That means no element of A is related to any element of B. No element of A is related to any element of B. That means R equal to null set. Null set you can write like this also. This relation is called empty relation. Empty relation or void relation. Okay. Now take fourth example. Let A equal to a set 1, 2, 3 and B equal to 5, 6. And let R be a relation from A to B defined as R equal to set of all xy such that modulus of x minus y is greater than or equal to 0, where x belongs to A and y belongs to B. Now find out elements of R. So R equal to, so take first element of A, that is 1. Take first element of B, 5. 1 minus 5. 1 minus 5 is minus 4, but 1 minus 5 is minus 4, but you take modulus of 1 minus 5, that is modulus of minus 4 is equal to 4. 4 is more than 0. That means 1 is related to 5. Same way you can check other elements also. What about 1, 6? 1 minus 6 is minus 5, but its modulus is 5 and 5 is more than 0 or greater than or equal to 0. So 1 is related to 6 also. Now take second element of A, 2. 2, 5. Because 2 is related to 5 because 2 minus 5 minus 3 and modulus of minus 3 plus 3 and 3 is more than 0. Same way 2 related to 6. Take third element 3, 5 because its modulus, difference of modulus will be 2 only, and 3 related to 6 also. That means R will get A cross B. R equal to A cross B. So if R equal to A cross B, then relation R is called universal relation. We denote it as U. It is the biggest relation and empty relation is smallest one. Okay. Let's consider one more example. A equal to set 1, 2, 3, 4, 5, etc. up to 10. Let R be a relation on A. Relation on A means relation from A to A. Defined as R equal to set of all xy such that y equal to x square, where x comma y belongs to Okay, because there is only one set. And once again, relation on A means relation from A to A. Now we can write elements of R equal to, when x equal to 1, what is the value of y? Y equal to 1 square, that is 1 1. So 1 is related to 1 itself. 1 belongs to the set A. Now take second element of A, that is 2. When x equal to 2, what is the value of y? 4. 4 is in this set. So 2 is related to 4. Now take third element, that is 3. When x equal to 3, value of y is 3 square, that is 9. 3 also in that set, so we can take 3 also. So 3 is related to 9. If we take 4, x as 4, what is the value of y? It will be 16. But 16 is not in this set. So R contains only 3 elements. Clearly R is subset of A cross A. Okay. Suppose we can ask question also, find R inverse. R inverse. R inverse means 1 is related to 1. This reverse relations. So element of R inverse will be 1 1. 2 related to 4. So element of R inverse will be 4 2 and 9 3. Can expect question like this. Domain of R. Domain of R means set of all x coordinates of R. X coordinates of ordered pair in R. So domain of R is 1 2 3. Right. X coordinates 1 2 3. Range of R. Range of R means set of all y coordinates of ordered pairs in R. So you want to write y coordinates of ordered pairs in R. Y coordinates means 1 4 9. So range of R, that is 1 4 9. Okay. So this much is studied in +1. So this is all about session 1. We'll get an assignment based on session 1. So tomorrow we can start session 2, that is +2 topic of relations and functions.